Hi guys, welcome to this tutorial. Today we'll be having a first lecture or class in physics. Alright, and we will be doing our best to deliver the best to you. Now, starting from the very top of our first topic in physics, fundamentals, units, and derived units. Okay, now what's the difference between fundamental units? Now, just as we all know that the fundamentals are talking about the basics, the ground, let's say the foundation, okay, the foundation of the building up of every other unit you get to meet in physics. Okay, now our fundamental units are the base units of measurements. Okay, they are the base units of measurements. One or more of our fundamental units are always seen in every form of measurements we get. Okay, now fundamental units cannot be further reduced. They cannot be further broken down. They are, let's say, would I say they are the life wires of every other unit. You can't break them down. You can't reduce them further. Okay, they are the building blocks. Okay, let's use it as the building blocks of every other derived quantities. And there are only 7 of them thus far in the SI system. Okay, in our metric system there are just 7 of them, and we have them as the meter, all right, the kilogram, we have the time, all right. So we have the meter, okay, this okay, we'll still look at it in dimensioning, all right. In dimensions is referred to as L. The kilogram in dimension is referred to as mass, and our time in dimension is referred to as time. Okay, now these are their dimensions, but we'll still see that in the course of our study. Okay, we have the meter, its unit is M, kilogram, its unit is kg, all right. Time, its unit is in seconds. Kelvin, the unit is K, that's representing temperature. Amount of substance, its unit is in moles. Then we have current, whose unit is in amperes, and candela, which unit is written as CD. Alright, now for the derived quantities are terms, are units expressed in terms of the fundamental units. So derived quantities are a combination of one or more of our fundamental units. Okay, now derived quantities can still be broken down to the fundamental units which formed them. Okay, that's why we say it can still further be broken down. All right, now there are a lot of derived quantities in the metric system. Unlike our fundamental units, there are just 7 of them. They are limited in number, but the derived quantities are lots more. Okay, now examples of our derived quantities are area, we have volume, we have density, we have acceleration, we have force, we have power, we have work, we have momentum, and we have pressure, and lots more. Name as much as you can that are your derived quantities or your derived units. Okay, next we'll be looking at will be the dimensions of how derived units are gotten from our fundamental quantities. So we'll be looking at dimensionings. Now, dimensions of physical quantities, okay, there are the 3 basic ones which we'll be using, which are our meter, which is dimensioned as length, okay, and kilogram, which is dimensioned as mass, and our time, which is dimensioned as weight. Okay, now for the length is any quantity which can be measured in units of length or meters. Okay, any quantity which can be measured in units of length, okay, bears L. So for length, is any quantity that can be measured in units of length. All right, units of length include meter, centimeter, millimeter, etc. Okay, now all the centimeter, millimeter can be converted to meter, which represents length. Okay, next, time is any quantity that can be measured in units of time. Example, we have hours, we have minutes, we have seconds. Okay, all these can be converted to seconds, which is a unit for time. Okay, now for our mass, this is L, this is T, and this is N. For our mass, any quantity that can be measured in units of mass. Okay, we have kg, we have grams, we have which other one? We have a kg, we have grams. Okay, any weight, any unit, etc., any unit that can be measured, all right, in units of mass. We have kg. As long as it's representing weight, mass, then it can be brought to this form. All right, these are the major three quantities or three units that we'll be using in dimensioning. Okay, now it is also important to understand that the symbols that are used to specify length, mass, and time, just as we said, are capital L, T, and M. Okay, so let's look at some derived quantities, okay, derived units and their dimensions. Okay, derived units and their dimensions. Let's start from the basic ones. We have area. All right, we know that area is what? Length times length. Okay, so area is length times length. Okay, area of a square or area of a rectangle is length times length or length times breadth. Now this L represents a quantity that is measured in what? Meter. All right, so that's why we have it as L squared. Okay, length. Since it deals with length, all right, since it's measured in centimeters, meters, millimeters, okay, it deals with length. Same for our volume, which is length times breadth times height. All these, all right, all these are units that are dealt under, are measured under what? Our length. So this becomes L cube. A dimension will become L cube. Length times length times length. Okay, forming L cube. Next we have is density. Okay, now we have density. Density, what's our formula for density? We have it as mass over volume. Okay, if we have mass over volume, Okay, now we know that our representation for mass is what? M. So this becomes M over volume we've gotten here as L cube. L cube. Alright, so we can leave it like this, or we put it as N L raised to minus 3. Okay, now that represents our density. Okay, next we can look at is acceleration. Now, what is acceleration? Acceleration is velocity over time. Okay, velocity over time. Now we know that velocity is speed. Okay, so if we look at speed, all right, speed is what? Distance over time. Okay, speed is distance over time. That means this will become, our distance is measured in meters or centimeters or kilometers. So this becomes, distance will be represented by L all over time, which is represented by T. So back to here, our velocity here will be what? So this will become L T raised to minus 1. So our velocity here will become L T raised to minus 1 all over T. Okay, so now velocity becomes L T raised to minus 2. Okay, remember that this is also minus 1. So it's like saying, looking at our laws of indices, we have minus 1 for T, since the same quantity gives us LT raised to minus 2. So our acceleration becomes LT raised to power minus 2, and our speed will be LT raised to power 1 minus 1. Okay, next we'll be looking at is force. Okay, we're seeing some other examples, so let's look at more examples. Let's look at force. Now, for force, we have it as mass times acceleration. Okay, now, all right, force equals mass times acceleration. Now, we've discovered that our mass is our m, and acceleration we've discovered to be what? LT minus LT raised to minus 2, LT raised to minus 2. So our force here becomes what? NLT raised to minus 2. Okay, all right, next we'll be looking at is work. So if we have work, all right, now work is force times distance. So we have force times distance. All right, now let's pause. Now we found force to be what? NLT raised to minus 2, and we know that the distance is n, right? Sorry, no, distance is our length, because distance deals with what? Kilometers, meters, centimeters, millimeters. All right, that deals with our distance. So now, multiplying this, what will our distance, our work be? The dimensions for our work will become mass, L times L, L squared, T raised to minus 2. I hope we are understanding this, and we see how easy it is once we know the basic unit that defines our work. Now, let's look at power. All right, now for power, we have it as work all over time. Okay, now as earlier defined, we've defined our work. So our work becomes what? NL squared T raised to power 2 all over T, which is for time. So this, our power becomes NL squared T raised to the power minus 3. Alright, now next we have momentum. Okay, momentum would give us what? Mass times velocity. Okay, now our velocity we found out to be speed. Okay, and speed is length LT, length over time. Okay, that means this becomes mass times LT raised to the power minus 1, which is NLT raised to the power minus 1 as our momentum. Now pressure, we have it as force times force over area. That's pressure, force over area, AREA. Okay, and force, we've learned force to be NLT raised to the power minus 2 all over area we have as L squared. Remember, our area is L squared. Okay, so this we have as NL raised to the power minus 1 T raised to the power minus 2. Now, how did we get raised to the power minus 1? This, when broken down, gives us N times L times, okay, N times L, let's have it all over L times T, because this is raised to the power minus 2. So one L cancels one L, leaving us with N over L times T squared. Okay, so this coming up will become N L raised to the power minus 1 T raised to the power minus 2. Alright, hope we understand that. Okay, next we'll be looking at is surface tension. Let's see. Surface tension. Alright, for surface tension, we have it as force over length. Okay, now force over length for surface tension, our force is NLT minus 2 and length is L. So this gives us MT minus 2 for surface tension. Okay. Alright, next we have is stress. Okay, now stress is something as pressure, which is force over area, and we've calculated that to be NL raised to the power minus 1, and so this could be force, pressure, or stress. Okay, so that could be pressure or stress. Okay, which other one haven't we seen? Okay, let's look at, before we call it a wrap, let's look at impulse. Impulse is a force times, impulse is force times time. Okay, force times time gives us impulse, and from earlier on we've learned that force is NLT raised to the power minus 2 times T. Okay, so this gives us impulse will be NLT, okay, raised to the power minus 1. Okay, alright guys, I guess with this we've done enough examples on dimensions, so we would like to call it a wrap. For you to assimilate this, you can work on more examples, and if there are any you find challenging, post it down at the comment section and we will simplify it for you. Alright, thanks so much guys for sticking with us, and don't forget to like, subscribe, and share this link with friends as it helps us to grow. Alright, and you will get notified as we post more videos. Thank you guys. See you in our next class.